So hello everybody, this is part 2 in the Avondale Audio NCC300 amplifier build, the big build I suppose you could call it. So in the first introduction in part 1 we built up these boards and we're now going to mount them onto this heatsink, which I briefly run over in the previous video. I have since drilled some mounting holes with some countersunk screws, which will be bolting this to my heatsink, my aluminium plate, which hasn't arrived yet. It's been over a week, should have been here, but we just have to go with the flow. When it arrives, it arrives. I'm ready to go, I'm ready to rock and roll. But in the meantime, I can mount these power amp boards to this heat spreader. So I'll just move this one, we'll do one at a time. Just move this one out of the way. I don't know how close I can get in. So what we have to do in effect is mount this underside. So we're going to need some sill pads, 203s for the devices. This has been thoroughly cleaned down prior to this, gone over it with some alcohol wipes, so it's all spotlessly clean. This is all clean, this is all clean, all cleaned off, all cleaned off. So the tricky bit is getting this on there. Thus we've got a bit of alignment to do. We're going to have to align, how we can show this, sorry, bang the camera. We've got to align thus, like that. All will become apparent. So the first thing, we're going to need a couple of sill pads. These are mica sill pads, nothing special, nothing exotic. Just going to take 2 for now, put the other 2 to one side. I'll just visually inspect them, make sure they're not cracked or got any obvious defects. These look very good. We need to apply these in their locations thus. So what I'm going to do is get just a little bit of paste, heat transfer paste, and I'm going to put this transistor on, and I'm going to put that transistor on that end there. That will become apparent as we move forward. So I just smear, just a smear like that, again just a smear over the area where the transistor is going to sit. We then get another smear, a little smear, a little tiny blob on here, thus, a little tiny bit, not too much, and we smear this with our finger, or fingers if you like, and totally cover the sill pad both sides, and then we can stick that one there. We'll do the same to this one. Again, there's various ways of doing this. Some people use a little brush. I just do this. It seems to work. So that one I go there. So we've got a little smear on there. This is where I need to just wipe my fingers. Because now what we're going to do, we're going to take a 15004. Brand new, out the packet. That doesn't even look genuine, does it? But these were bought from Avondale. That looks well suspect to me, but we're going to, the way that writing has been stamped on that device, so I'm just going to check this Yeah, PMP, emitter coil base, and it's got HFE of 215. OC current 2.5 milliamps, base emitter 0.594, test current 4.35, leakage 0. So that tells me everything's hunky-dory and fine with that device, and we're going to put it in. We're going to be using it. So a little bit of grease on there, again with my finger. I'm just going to coat this, maybe a bit more than that, around the edge. Clean my hands, and this one's going to drop in there, like that. So now what I do, get me screw, drop it through, just got to a line, excuse me, put that over there a second, just to line that one through there. The board itself you have to offer up. This is a bit fiddly, I'm doing this behind the camera, it's a bit fiddly. I've got a little screw. There are spring washers I'm using. This first one is probably the most difficult. As you can see, to get your fingers in there, it is difficult using this U channel. It is a bit difficult. Especially with my sausage-like fingers. So I've got my spring washer on there. I'm just putting the back nut on, and once we get this in place, this will hold the whole thing quite steady for when we move forward, and we're going to fit the other end now. So I'm just going to apply a little bit more paste to here. There we go. Too much now, I suppose. No, that's okay. It can dry out in use. There we go. A bit more grease on that. If you put too much, it actually has an adverse effect. So it's 104. This end 15003. So that's the other type. So here we have 15003. On semi from Farnell, direct. That looks more respectable, doesn't it? We'll check it. .64. 4.2 zero leakage. That's perfect. Now, a lot of people, that's 64, but the one in there is a lot higher HFE. It doesn't matter a jot. I have tried to match these over the years. It does. You can match them. I can't hear any difference. It doesn't seem to detract from the operation of the amplifier whatsoever. So just put them in what you've got, doesn't matter. Check them that they're okay, of course. Last thing you want is to put a defective device in straight away. Okay, a good smear around like that, just a smear up in between the legs, lovely. And this is where it takes a little bit of lining up, because we've got to line up all the holes. Clean our fingers. Bear with me. Oh, that was easier than I thought it was going to be. So that drops straight in. Blimey. This is all going too well. Again, a spring washer. If we can see that. I'm going to drop a spring washer on there, back nut, throw a back nut on, so I'm not nipping these up tight. I'm now going to go along, fit another bolt, another washer, another screw, nut, and again up here this end. This one's a little bit more, not quite as easy. I'm just going to slacken these slightly now so I can give myself a little bit of play so that the whole thing moves, and this should in effect spin in. Well, it's just gone straight in now. So that's another one, gone straight in. Another nut. So that's the first two devices in. Now I'm going to quickly carry on and install the other two output devices. Again, I'm just checking, visually checking, there's nothing wrong with them whatsoever. And I'll carry on, install these as I did the others. And I'll be back. So I've quickly gone along, we'll clean up all these, the little bit of smear afterwards. I've quickly gone along 15003, 15003, 15004, 15004, and we've put all our spring washers and nuts on. I'm looking on the end, on an end game. Will it play ball? No. But anyway, what I'm going to do now, I've got a little M4 spanner, socket head, so it's a ball head, and I'm just going to go along and just quickly, not just, all I'm doing is just giving these just a little turn, bit by bit, not over tighten them at this stage. I'm just equally pulling the board down onto those nylon bushes, those shoulder bushes. We just move along so that everything's seated nicely and not overstressed. So now we can come to the middle, and I'll give it some more torque, a little bit more, a little bit more, and just gently, 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 gently. From the inside out. So now I can give it a little nip, bit of pressure, not too much, just enough to, we're not holding up the Golden Gate Bridge, just a little nip so that they're firmly home, each one. If they come loose and the device moves away from the heat spreader, they do get rather hot and they tend to go pop and short out. So I'm happy with that at the moment. Excuse me. And if you recall, and mop some of this mess up here. Little device here, I have some thermal epoxy which will be applied to that, so that this device will be well, it is already in close contact, and actual fact that's too close. I don't know if you can see that. That leg is touching, or I believe it is touching. I'm going to have to sort that. This is DIY for you, isn't it? Okay. This leg on this device is too close to here, so I'm going to have to tease this back to make sure there's no contact. I'll be back soon. So I don't know whether you can see that, whether it's focused in on that, but I managed with a soldering iron just to release that leg, move it across slightly and bend it clear. I should have given more clearance on this spreader, or in actual fact this board might belong to this end, but anyway, I'll resolve that issue. It's quite clear, there's no short, so that'll be fine. So we made good progress there, sorted a little issue out here. It's not the best, but it's fine. And our next port of call is to check that we have these devices are isolated from the chassis, as it would be, or this heat spreader. So I've just got a multimeter and there we go. So I'm just going to hook it on here. Correct. Now we go to the chassis. Should have nothing, 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 nothing. Other way around, if you like. Chassis, nothing, nothing. Brilliant, that's fine. Lovely. So this continuity checks out, it's fine. What I'm going to do now is repeat the same process and put the second board on just like this. So I'll be back when I've done that. So that's this side in, exactly the same procedure. Board 2. I'm just going to do a continuity check just to make sure that all is well as before, that none of the devices are shorting out against the spreader. So we'll on there, that's correct, and we'll go along each device, nothing. So that's good. Swap them round just in case. Nothing, 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 nothing. All good and excellent. So we can do away with that now for the time being. We can do away with all this rubbish. I'm going to get rid of all that in a minute. But now we have a task of soldering these output legs onto the PCB. It's not overly difficult, it's just uncomfortable. So I'm just going to have a bit of a clean up here. We've checked the continuity, all installed, lovely, hunky-dory. There's our tandem NCC300, as I'm going to call it, and I'm just going to go along now and a time of no return really. We're going to solder. I might have to just get a bit of light on there. Go along and solder these devices onto the PCB. So away we go. First one. 1, 2, 3. 1, 2, 3. This is how I do it. Anyway, 1, 2, 3. You've got to feed enough solder in to wick around the leg of the device. 1, 2, 3. Like that. 1, 2, 3. 1, 2, 3. 1, 2, 3. Stop that. Move along, move along. As I stated before, I haven't got an extractor. Well, I have, but it's buried in the garage, having moved house not so long ago. But I've just over my left shoulder is a window which is open. It's a beautiful day outside today. It's the 21st. We've just been told that they're extending the lockdown in the UK. So I'll just carry on doing DIY, I think, a bit of electronics. 1, 2, 3, there you go. So that's pretty much that complete now. Can't get the light in there, but so there it is. Is it a thing of beauty? I don't know, probably is. In some areas of engineering you could call it a thing of beauty. So I will carry on, and this is going to be installed into a case, but before that it's going to go onto a heatsink, which I'm waiting for. So see you later. So welcome back. I've now fixed the cap 6s and the transformer onto this bottom tray. It's I've used a suspension system for this transformer, grommets and some nylocks. I'm leaving these bolts long. I may put some shielding. I might use these to put some shielding around this transformer. Some what I call new metal. I may not need it, but I'm just leaving those in situ. If I don't do that, don't need to do that, I will chop them off at a later date. So that's that bit. I've also drilled some holes and put some speaker terminal 4mm bonding posts, some RCA or phono sockets. I've cut my own hole for my own fuse switch IEC. I'm going to put a blanking plate over this. I've got nothing that fits this really, so I've used my own, and I've left an area here. This area in here, I've left that quite blank because what I want to put in there is a speaker protection circuit. Whoever's, I don't know yet. So that goes there, and as before, you've seen all this. That's going to be fitted in here. I ordered a big chunk of aluminium to be used as a heat sink under that. 5mm aluminium, 400 by 200 by 5mm thick, and they sent me 300 by 200. No good at all. So I might just use this temporarily just so that I can progress the job, but they're sending me another piece of this, the correct size, to use as a heat sink. But as I say, I might use this one just to keep pushing the job forward, otherwise I'll be waiting for this. This is taking nearly 10 days to get here. A bit frustrating, but that's the way it is at the moment. You've got to live with it. So just slow down, that's what they say, slow down. So that's it for this bit so far. When I've fitted all this and I'll start wiring it up, we'll come back. I think some of the routing, the cable management, needs to be carefully thought out here. This end's all done with. AC, I've got to come in here, go around, up and round. I think I've got to go up and round and drop down to feed here, and there'll be a nylon connector block to feed this dirty grate. I think this, I've spoken to Avondale, I think this is an 800 VA transformer, an AST transformer from way back when, but it's still perfectly beautiful. It's a beautiful thing, and I've used it, as I said, in many applications, many amplifiers, and it works very, very well. Super quiet. So that's it for now. See you soon. So I've pushed on a bit. I've mounted this heat spreader on a piece of aluminium. This is, as stated before, this is not the correct piece of aluminium. It needs to be much wider, but I don't know how long it's going to be before it gets here. It's taking a week to 10 days for the correct size. But as a temporary fix, I've fixed this to the bottom plate via some standoffs. This is fixed to this with some heat paste under the joint here, and that should be enough to take away the heat that's generated. I will set up the bias so that it's optimum for that anyway, and I've done some initial wiring on this one, and you'll see the positive red goes to the positive. This black here comes all the way down and actually feeds to the negative speaker terminal here, and you'll notice that's on the dirty end, the closest end to the transformer. All the 0 volts off this board go back to a single point here, a star point here on the PCB on the cap 6, negative blue, and this red wire comes off of the speaker out here. So at this stage, this side is ready to power up, which is my next stage, and test and set up bias and check the offset. Once we've done that, it will be a copycat over here. Then I have to connect up the signal input. This board will be supplied from the top phono in here, just a short run. The bottom one will be this board, and there's a longer run over here, excuse me. So it's just a matter of being patient, making good connection on your spades, and a nice route. I didn't know which was the best route to take, so I've taken the shortest route, which is across there. So this with the lid on, these are 10 mil or so below the top of the lid cover. So you'll see that the flutes on the bottom mounting here, and so this piece of aluminium is about 7 mil above these flutes, these air holes if you like, slots. So my theory is that the heat that's generated via these two boards, or the output devices, is dissipated through this sheet of aluminium. The heat rises from the bottom, envelops this piece of aluminium, comes from the outside and out through the top, through the vents on the top. That's in theory. I'm sure it'll work fine. I've built quite a few of these without any vents whatsoever. Indeed, if you fit them in a 250, you've got no vents. You've got just a big chassis taking the heat away. So that's my next process, is to check that we've got our 50 volts at the supply, and then connect this up to this. You'll notice I haven't as of yet installed some jumpers. I need to put some jumpers just in here. Power comes in here, feeds this front end. It also feeds the rest of the power supply, plus and minus, down through here. So I've got to put a little jumper in there. I just use a piece of wire, but you can buy some little pins and some plugs. So that's my next step. I've wired up the AC here. Goes through some nylon blocks at the back that feeds the transformer. I don't know whether you can see or not. I've powered it up. The Cap 6s are now live, and we should have around about 50 volts plus or minus. I've disconnected all the wiring, so now we just check that we have what we're supposed to have. So we should have around about 49-50 volts. If I can get this on here, bear with me, I'm working around this camera. Get on. Ready, power on. So we have 49.4 positive, and this side should be negative. Yes. So now I'm going to move on and connect this board up and start doing some tests. Before I do any of that, I've checked that everything's okay up to this point. We know that we've checked everything on this board, the power supply, blah 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 blah. I'm not going to bore you with it all again, but before I put 50 volts onto this, I'm going to double check that everything's correct. I'm looking for any little slither of wire or a little bit of solder that may short anything else, and I may go along and just brush off with a brush everything, make sure it is safe to put power on it. So I'll be back. I've just double checked everything. I have this meter is checking my DC offset. This meter is checking my bias. Everything's connected. I've double checked, triple checked, made sure everything is fine. We're now going to power up live, first time. Always a nervous position to be in, but I'll power up and check the offset. If the offset doesn't come down straight away, I'll power off. So ready, here we go. $10 millivolts of offset. I'd say that was pretty darn good coming down. I'm now going to connect to the bias, see what we've got on the bias. .92. Now I'm going to leave this for a little while just to make sure there's nothing gone pop, no smoke. That's pleasing, isn't it? That's fine. I'm going to take this up to 2. It's slightly different now. We've got a load. Oh, did forget to mention, I put a couple of links in here, this side and that side, so that the power actually reaches this end of the board. That's fine. Great. So I'm just going to tweak this up a bit to about 2 volts, I think. If it'll go, here we go. Gently, gently, gently. Up we go. Everything's fine still. 2 volts. Offset is still at 10 millivolts. Quiet as a mouse, that's lovely. No drama at this stage. I'm just going to let that soak for a while. That's smashing. So this is good. Offset 10 millivolts. So I'm going to tweak the bias a bit more. Sorry, not the camera. Tweak it up. .1. Leave it. Still no heat. And there's a bit of heat on these drivers now. These are just warm, hardly anything. So it's been about 20 minutes. And I've wound this up to 2.2, 2.3. Offset is 8.4 coming down. And we have a temperature on this of about 30 degrees. And the transistor's 30 degrees, 28, 24. So it's getting away. I think this is too high. I'll wind this back a bit, so 2.25, and leave it for another half an hour. Then monitor the temperature then. I mean, bearing in mind there's no load on this whatsoever at the present second. So I've just got to get to an equilibrium, bearing in mind there's 2 on this one heatsink. They're just warm. These are warm. Just a little bit of temperature on the regulators. So I'll be back in about half an hour. Just leave it on the bench, soaking away, saturating it with a bit of heat, and we'll come back and see how we do. So it's been another 20 minutes or so. We're now down to 8.6. That floats around about that at 2.25 volts. The temperature has come down a bit, 27 on the spreader. I'm happy with that at this stage. I'm going to wire up this side now and set up this side just as I've done this side, and then we'll power up both at the same time. Let it saturate, let it soak, and just gently adjust the bias so that everything's hunky-dory. But as it warms up, as it burns in, this will come down even further to about 5, I think. 5 millivolts of DC offset, which is superb. But initially it starts off around about the 10, floats around about the 10. As you can see, it's starting to come down slowly as it thermally saturates. So see you in the next bit. So we're now going to test this side. This is disconnected this side. Do one side at a time. There's nothing connected this side. Here's the offset connected to the speakers down here, and the bias is over here. So again, deep breath, checked, double checked, triple checked everything, brushed everything off. Nothing left but to hit the button. Whoops, that should be millivolts. So we've got 2 volts of bias. Remember, on the bench we set it up for 2 volts. We got 5 milliamps of DC offset, slightly better than this one at this present stage. There's nothing getting hot. That's fine. This is steady, that's steady. Just waiting a little while just to check everything's fine, which it appears to be, which is always a good thing. Just get my twiddler. If you remember, we set this one up for 2.25 volts of bias, so I'll do the same on this side in stages. So we'll go to 2.1 to start with. No issue so far. That's exactly 2.1. So I'll leave it like that for 20 minutes. Let it saturate. Very good DC offset here, 5. That's excellent. I've got no idea why this one is slightly higher than this one. This board. Probably these transistors are a better match for that. No drama. So I'll come back shortly. I've now ramped this up to 2.2. Just starting to warm up now. These are still stone cold, but these heat sinks here with driver transistors there just starting to warm. So I'll give it another 20 minutes and come back. Been some time. So we've got 2.25. These are nice and warm. Just a bit of temperature in those, very little. So what I propose to do now is to power off, connect both of the boards up, power on, and we'll do a final adjustment. So I'm going to power off. So this is the final part in this section of the video. Excuse me. So just to recap, I've installed this heat spreader onto a plate which isn't the correct plate. I've got to retrofit a bigger plate which is in transit as we speak, but I've wired it up. As you can see, we've done our initial test board on board. I've now reconnected this power supply to this board. This one's connected up here. This board on the right is off this meter. This board is this meter here. So this is the biggie. We're going to fire up both at the same time. Hopefully there'll be no smoke or anything. That's pretty good. So I've just finished this one. So this will come down, I believe, or I hope it will. I might have left it on 2.3, but I'm going to balance these so that they're both the same. It looks like I did leave that at 2.3 actually. So that's a good thing, isn't it? So now I can see the difference. So initially what I'm going to do, because this was at about 27 degrees I think, I'm going to tweak this up to 2.3. Slowly, gently. Oops, come back a bit. There's a little bit of lag, just got to be gentle. Gently, 2.3, there we go. So I'm just going to leave those, give them an hour or so. We'll take some temperature readings. Where we are. So this spreader plate is 23, the ambient temperature 23, 24, so 24, and we'll see it's 24, 25, 26. We're just going to watch and see. I'm hoping to run these around about maybe 30 degrees and see if it can balance. The heat sinking will thermally balance with the bias. So we'll wait and see. I'll be back shortly. After a short period, I'll say 30 minutes, the heat sink heat spreader was getting too warm. I thought it might have been with two boards on the same bit of alley, but we're 27 degrees, 30 degrees this end. So I'll wound this back to 2.2. I'll leave it for another 30 minutes. I might have to wind it back a bit more. We'll see. But there's no drama. This ambient temperature is 24. This heatsink that I put in the bottom here is starting to warm up slightly. So it's just a matter of suck it and see, wait and see. Be back soon. This has now been on the bench, ticking over, soaking up the heat for 12 hours. This is the next day. Actually, I left it on all night from my last little snippet on the video. This hasn't moved much. 2.2, 2.2. I'm very happy with that. And we have 26 degrees thereabouts everywhere. 24, as that will disappear, that gets less and less as we go away. So this heat sink at the bottom that I'm using is actually working very well. Excuse me. So this part, this element of the works is complete. The thing is set up, ready to rock and roll. Apart from, I need a few things I need to do. I want to bond the earth to the chassis, and I've don't know if you can see that. I've cut away the paintwork or the anodizing. There's a little patch you can see there, and I will strap this, drill a hole, and with a nice star washer. You pay all this money for an autofocus camera. Does it do it? No. There you go. So I've got a nice star washer, and that'll be bonded to ground, to earth. That makes it safe. What else have I got to do? The signal wiring, I need to have a little check. I've got some cheap and cheerful stuff in there, just pro tem. But what I propose to do is put the lid on and fire it up in a system and have a listen. Hopefully there's nothing untoward. There shouldn't be. That will be in the next video, the final video of this NCC300 build. It's all gone pretty well. No dramas. I don't believe we had any dramas. No, I don't think we did. As always, it's a little bit concerning when you power up from cold, from a new build. Will something go pop and the magic smoke come out? But we had none of that. So thanks for watching. Please leave your comments below. I don't mind ridicule and criticism. Doesn't bother me in the slightest. But yes, thanks for watching. I hope it was of interest, or entertainment, if you like. Call it entertainment, and it may help those that have these boards kicking around on their benches doing nothing. So keep well, everybody. Keep safe. look after yourselves. The Verda, the implementer. See you in the next video.